Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I would like to learn more about your study on Python class and data class concepts. Could you please explain to me the main ideas and contributions of your study?
Certainly. Our study focuses on introducing the concepts of classes and data classes in Python, as well as their importance and use cases in object-oriented programming, UPET. The main idea behind our study is to help readers understand how classes and data classes work and how they can benefit their programming projects. We explain that OP is a programming paradigm that organizes code around objects, which are instances of classes. Classes serve as blueprints for creating objects, providing both data and functions, methods that operate on that data. In Python, data classes are a useful tool for reducing code redundancy and making classes less verbose. They are primarily designed for classes that store data, but can also include methods. One of the main contributions of our study is explaining how data classes can be used to simplify the creation and manipulation of objects, providing basic functionality such as instantiation, printing, and comparison without the need for additional code. We also highlight the use cases of data classes, such as bank account classes, scientific study content classes, and employee information classes. By demonstrating these practical examples, we aim to illustrate the real-world applications of data classes and how they can improve code organization and maintainability. Overall, our study aims to provide a clear and comprehensive introduction to classes and data classes in Python, helping readers understand their purpose, how they work, and why they are important in modern programming.
Thank you for providing an overview of your study. It sounds like you covered a wide range of topics related to classes and data classes in Python. To delve deeper into the concept of data classes, could you explain how they differ from regular classes in terms of syntax and functionality? What specific features or benefits do data classes offer that make them useful in certain scenarios?
Data classes in Python offer several features and benefits that make them useful in certain scenarios. Firstly, data classes reduce code redundancy and make classes less verbose. They provide a convenient way to define classes that mainly store data. So, with just a few lines of code, you can create a data class that automatically generates common methods like init, repr, train, crash, and stra. Wonderfully, this saves you from writing repetitive boilerplate code. Secondly, data classes provide a clear and concise syntax for declaring and initializing instance variables. Instead of manually defining each variable and writing their getter and setter methods, you can simply define the variables as class attributes. The @dataclasses decorator takes care of generating the necessary methods for you. Thirdly, data classes support easy comparison and printing of instances. The generated key method allows you to compare instances for equality. And the reprep and atree methods give you a readable res study of the object. In terms of functionality, data classes work just like regular classes. You can define methods within a data class that interact with the data stored in its instances. This allows you to add custom behavior to your data class according to your specific needs. However, data classes have a few differences in syntax and functionality compared to regular classes. The main difference is the use of the @dataclasses decorator, which enhances the class with features mentioned above. Regular classes require you to manually write the boilerplate code for common method. Another difference is that data classes have an optimized attribute access speed and memory usage through the use of the slots class variable. This can be beneficial in scenarios where performance is critical. However, it also brings some limitations. such as the inability to dynamically create attributes after initialization and increased complexity when using multiple inheritance. In summary, data classes offer a more concise syntax, reduced code redundancy, automatic generation of common methods, and optimized attribute access and memory usage. These features make data classes a convenient choice for classes that primarily store data, such as bank accounts, scientific studies, and employee information.
Thank you for the detailed explanation of the features and benefits of data classes in Python. It's clear that data classes provide a more streamlined and efficient way to define classes that primarily store data. In terms of use cases, you mentioned bank account classes, scientific study, content classes, and employee information classes as examples. Could you elaborate on how data classes can be specifically applied in these scenarios?
Data classes can be specifically applied in scenarios involving bank account classes, scientific study content classes, and employee information classes by simplifying the implementation of these classes and reducing code redundancy. For bank account classes, a data class can be used to store the account holder's name, account number, and balance. By using a data class, you can easily instantiate and compare different bank account instances. Additionally, data classes provide a convenient way to define the attributes of the bank account, making it easier to understand and work with the code. In the case of scientific study content classes, a data class can be used to store the title, author, publication date, and abstract of the study. Data classes allow you to quickly create instances of the study class and compare them based on their attributes. This makes it easier to organize and analyze a collection of scientific studies. For employee information classes, a data class can be used to store attributes such as name, age, position, and salary. By using a data class, you can easily instantiate and compare different employee instances. Data classes also provide a convenient way to define methods that interact with the employee data, such as calculating the employee's annual salary or updating their position. Overall, data classes simplify the implementation of these scenarios by providing a concise way to define the attributes and behavior of these classes. They reduce code redundancy and make it easier to work with and manipulate instances of these classes.
Thank you for providing specific scenarios where data classes can be applied, such as bank account classes, scientific study content classes, and employee information classes. It's clear that data classes offer a streamlined and efficient approach to defining and working with classes that store data. In the context of object-oriented programming, you mentioned that data classes are part of the larger concept of classes. Could you explain how classes are fundamental to object-oriented programming and how they enable code reusability and maintainability?
Certainly. Classes are fundamental to object-oriented programming, OOP, because they provide a way to organize and structure code. In OOP, code is built around the concept of objects, which are instances of classes. Think of a class as a blueprint or a template for creating objects. It defines the properties, data, and behaviors, methods, that the objects will have. By defining these properties and behaviors in a class, we can create multiple objects with the same structure, but potentially different data, dat. Now, how does this enable code reusability and maintainability? Code reusability. With classes, you can create objects that have the same structure and behavior. This means that you don't have to write the same code over and over again for each object. Instead, you define the class once, and then create as many objects as you need. This saves time and reduces code duplication. So, if you have a set of functions that are commonly used in multiple parts of your program, You can define them in a class and create objects to reuse those functions whenever needed. Maintainability. As your code base grows, it can become difficult to manage and update. Classes help in organizing and encapsulating related data and functions together. This makes it easier to understand and modify code because the logic is grouped in a meaningful way. If you need to make changes to a specific behavior, you can update the corresponding method in the class, and it will automatically affect all the objects created from that class. This makes maintenance and debugging more manageable. In summary, classes in UP provide a way to organize code, enable code reusability by creating objects with the same structure and behavior, and improve maintainability by encapsulating related data and functions together.
Thank you for the clear explanation of how classes are fundamental to object-oriented programming and how they enable code reusability and maintainability. It's evident that classes provide a structured and efficient way to organize code, leading to more scalable and maintainable software projects. In the context of the study, you mentioned the importance of classes in simulating multiple objects and persisting objects in memory. Can you provide some examples or scenarios where simulating multiple objects and persisting them in memory using classes would be beneficial?